Right class, let's go to the last topic. Okay, how to find the maximum and minimum points of the function. Okay, so to determine the maximum or minimum points is by using the second derivatives. Okay, there is a step here. First step, from the function, okay, the function that will be given, you need to find the first derivatives. Okay, that means you have to differentiate, okay, to find the first derivatives. And then second step, you need to find the critical value. CV, it is a short form for critical value. Okay, what is critical value? That means you need to find the value for x. How to find? From the first derivatives, you need to equal 0. Okay, first derivatives equals 0. Okay, to find the critical value. And then third step is, from the first derivatives, you need to find the second derivatives. That means you need to differentiate twice, okay, to find the second derivatives. And then step 4, substitute the value x into second derivatives. Okay, where is the x? That means from the second step, the critical value for x. Okay, from the second step, you need to substitute into second derivatives. Why? To determine the maximum or minimum points. Okay, if you get the value for second derivatives less than 0, that means it is a maximum point. Okay, so the concave is down. Okay, if you get the value for second derivatives more than 0, it is a minimum point. So the concave is up. Okay, and then step 5, you need to find the inflection point. What is inflection point? Okay, let's say we have a graph here. This is x, this is y or fx. Okay, let's say this is a graph. Okay, so we know that this is concave down. Okay, concave down. Concave down, that means it is maximum point. Okay, and then this is the concave up. Okay, concave up, it is minimum point. Okay, point dia dekat mana? Kat sini point dia. Okay, where is the inflection point? The inflection point dia dekat sini. Okay, inflection point, that means it is exists when the concavity is changes. Okay, when the concavity is changes from downward to upward. Okay, or otherwise from upward to downward pun boleh. Okay, there is inflection point here. Okay, so the concavity is changes from downward to upward. So the inflection point is exists here. Okay, this is inflection point. Okay, inflection point exists when the concavity is changes from downward to upward or upward to downward. Okay, you found now? So this is inflection point. How to find the inflection point? Okay, you need to find the second derivatives is equal 0. Okay, there are two steps here. First step is second derivatives must be equal 0, and the second step is you need to find this the third derivatives. Okay, you need to find the third derivative. That means you need to differentiate 3 times. Okay, and then the value must be not equal 0. Okay, boleh nampak tak? Okay, the value must be not equal 0. Okay, bila dua-dua ni satisfy, that means it has inflection point. Okay, so nak lagi faham, kita tengok pada example. Okay, look at example 1.25. Okay, yang lain-lain ni sama je step dia. Okay, that means you need to find the maximum and minimum point. But I want to show you the last example. Okay, last example. Example 1.25. Okay, so look at your notes. Okay, it gives us y equals to 2x cubed minus x square minus 8x plus 5. Okay, and then the first step is you need to find the first derivatives. That means you need to differentiate. Okay, y equals to fx. Okay, dia sama dengan fx ni. Okay, y equals to fx. Okay, dia sama je. Okay, so you need to differentiate to find the first derivatives. So differentiate to x cubed, you will get 6x square. Okay, and then differentiate negative x square, you get negative 2x. Differentiate negative 8x, you get negative 8. Differentiate 5, you get 0. Okay, and then this is the first step you have done. Okay, second step, you need to find the critical value. Okay, find the critical value. Okay, how to find? First derivative must be equal 0. Okay, so this is the second step. So f prime x equal 0. Okay, and then we know that f prime x, this one, 6x square minus 2x minus 8. So 6x square minus 2x minus 8 equal 0. Okay, and then this is quadratic function here, the quadratic equation here. So use your calculator. Okay, guna calculator to find the value x. Okay, calculator mode tu. Okay, bila awak guna calculator, okay, 6x square minus 2x minus 8, okay, awak guna calculator yang awak kena cari yang tekan calculator, tekan mode dia tu. Okay, awak akan dapat sini 3x minus 4, this one x plus 1. Okay, and then so the critical value dia 3x minus 4 equals 0. So x equals to 4 over 3, and then this one x plus 1 equals 0. So x equals to negative 1. So this is the critical value. Okay, x equals to 4 over 3, x equals to negative 1. This is critical value here. Okay, the critical value. Okay, and then the third step is you need to find the second derivatives. Okay, from the first derivatives here, you need to differentiate to find the second derivatives. Okay, so this is first derivatives, 6x square minus 2x minus 8. Okay, and then first derivative is differentiate 6x square, you get 12x. Differentiate negative 2x, you get negative 2. Okay, so this is second derivatives. Okay, and then what's next? Step 4. Step 4 is substitute the value x into second derivatives. Okay, if you get less than 0, there is a maximum point. If you get more than 0, there is minimum point. So let's do this, the step 4. The step 4 is x equals to 4 over 3, right? Okay, when x equals to 4 over 3, and then you need to substitute into second derivative, 12x minus 2. Okay, so from the second derivatives, 12x is 4 over 3 minus 2. Okay, and then you can calculate. Okay, you can calculate, you will get 14. Okay, you will get 14 here. Okay, so 14 is a more than 0, is a positive value, more than 0. So you need to describe. Okay, at x equals to 4 over 3, there is a what? When more than 0, there is a minimum point. That's it. Okay, to describe. Okay, this is for x 4 over 3. What about x equals to negative 1? At x equals to negative 1, substitute into second derivatives. 12x minus 2, right? Okay, so x equals to negative 1 here. Minus 2. Then you need to solve. You will get negative 14. Okay, so negative 14 is less than 0. Therefore, you need to describe at x equals to negative 1, there is a maximum point. That's it. So we can know the minimum point and maximum point. Okay, at x value 4/3 and negative 1. Okay, and then last step, you need to find the inflection point. So how to find the inflection point? This one. Okay, second derivative must be equal 0, and then you need to differentiate to find the third derivatives, and then it must be not equal 0. Okay, so second derivatives this one. Okay, second derivative this one, 12x. Boleh nampak dah? Okay, 12x minus 2. So from the second derivative equals 0. So 12x minus 2 equals 0. We know that second derivative is 12x minus 2. And then masukkan dalam ni. Okay, 12x minus 2. So 12x, negative 2, move it to the right side, it will be positive 2. And then x equals to 2 divide 12, you get 1/6. Okay, and then you need to differentiate. Okay, differentiate to get the third derivatives. Okay, from the second derivatives here. Okay, saya tunjuk kat sini Nana. Okay, from the second derivative, you need to differentiate to get the third derivatives. So differentiate 12x, you get 12, and then differentiate negative 2, it is 0. So 12 is not equal 0, right? Therefore, at x equals to 1/6. Okay, at x equals to 1/6, there is an inflection point. Okay, there is an inflection point. Okay, you faham now? So we have 3 points here. Okay, minimum point, maximum point, and inflection point. Okay, what if from the second derivatives we have square here. Okay, macam mana kalau ada square kat sini dekat x? Okay, ni contoh So to differentiate, to get the third derivatives, differentiate 12x square, you get 24x, right? So how to do with x? We know that second derivative, we get the x is 1/6, and then 1/6 you need to substitute into the third derivatives. Okay, to get the value, it is less than 0 or equal 0. Okay, or more than 0. Okay, because we need to get the satisfied f. Okay, to get the satisfied, the third derivative must not equal 0. So bila ada x kat sini, then awak ambil from the second derivative ni yang x equals to 1/6, substitute into x. So 24 times dengan 1/6. So 6 divide 6, you get 1. 24 divide 6, you get 4. The answer is 4. 4 is not equal 0. That means there is the inflection point is exist. Okay, boleh faham dah? Ni contoh kalau ada x kat sini untuk the third derivatives. Okay, kalau tak ada macam tadi tu, that means not equal 0 jugalah. Okay, boleh faham dah? And then how to draw the graph? To draw the graph, okay, ingat we have 3 point here, maximum point and minimum point, maximum point, and inflection point. So we have 3 points to draw the graph. Okay. Sini x equals 2. 4 over 3. And then x equals to negative 1, and then x equals to 1 over 6. Okay. To draw the graph, okay, kita nak lukis graph, kita kena ada point x and y. Okay, so sekarang kita tahu nilai x saja. How to get the value for y? To get the value for y, okay, from the equation. We know that equation give us the function y equals to 2x cubed minus x squared minus 8x plus 5. So this is the function, okay, that gives you. Okay, so from the point that we have done minimum point, sorry, this is maximum point, minimum point and inflection point. So we can get the value for y. How? You need to substitute the value x into this function. Okay, so 4 over 3 cube minus 4 over 3 square minus 8 times 4 over 3 plus 5. Then you have to solve. Okay, you have to solve. You will get 4 over 3, okay, negative 73 over 27. Okay, kalau tengok pada notes awak tu. Okay, ini saya refer pada notes. Okay, and then for point x negative 1, substitute into this function. 2 negative 1 cube minus negative 1 square minus 8 negative 1 plus 5. Then you will get 10. Okay, and then last one for inflection point, y equals to 1 over 6 cube minus 1 over 6 square minus 8 times 1 over 6 plus 5. You will get the inflection point is 49 over 18. Okay, so the point for value maximum point is 4 over 3 negative 73 over 27. Okay, for minimum point negative 1 10. For inflection point is 1 over 6 49 over 18. Okay, so we have 3 points here. So to draw the graph, okay, to draw the graph, let's say this is the graph, x axis and y axis. So 4 over 3, okay, 4 over 3 negative 73 over 27. Point dia dekat sini. Okay, ni saya just sketch saja. Okay, just sketch saja. Okay, and then negative 1 10 dia dekat sini. Negative 1 10, let's say kat sini. Okay, and then inflection point dia kat sini. Okay, we know that this point is maximum point, right? This is minimum point. This is inflection point. IP inflection point lah. Okay, so maximum point, the concave is downward. Okay, the concave is downward. So maximum or minimum? Wait, sorry, balik. This is minimum. This is maximum. Okay, so minimum point, the concave is upward. Okay, the minimum point, the concave is upward. So it is be like this. Okay, for maximum point dekat sini negative 110, the concave is downward. And then we have inflection point. And then awak just sambung saja. Anda sambung saja dia macam ni. Okay, saya lukis tak cantik sikit. Awak lukis tu bagi cantik lah. Okay, so this is maximum point, inflection point and minimum point. So awak markkan dia. Okay, marks the point. Okay, this is 1 over 6 49 over 18. And then this is negative 1, 10. And then this one is, yang ni, yang garis-garis ni apa ni? This is function dia, yang ni. Y equals to 2x cubed, x square, negative 8x plus 5. This one. Yang function yang garis-garis ni adalah function yang dibagi ni, soalan dia. Okay, so we get the minimum point, inflection point and maximum point. Okay, you faham lah? Maaflah, saya lukis buruk sikit. Okay, kalau tak faham boleh tanya dalam WhatsApp, okay?